Based on existing research, one of the prime locations to look for intermediate mass black holes is within the core of globular clusters. A globular cluster refers to a tightly bound system of thousands to millions of stars held together by gravitational forces, all originating from the same molecular cloud. These clusters are commonly situated on the outskirts of galaxies, revolving around the galactic center. To date, some potential intermediate mass black holes have been pinpointed within such clusters, encircling our very own Milky Way galaxy. Nestled approximately 6,000 light-years from Earth within the constellation of Scorpius, Messier 4 stands as the nearest globular cluster to our planet. It has an estimated age of 12.2 billion years and measures 75 light-years across. Scientists analyzed 12 years of data from the Hubble Space Telescope and combined it with information from the Gaia mission. This collaboration aimed to closely examine the stars at the core of this cluster. By doing so, the researchers tracked the precise movements of 6,000 stars within this cluster. When astronomers closely studied the orbits and velocities of these stars, they found something strange. The stars were being influenced by a dense mass of nearly 800 solar masses situated at the cluster's center. Despite M4 being the nearest globular cluster, it's still impossible to resolve the individual stars at its densely packed core. But there's a clever way to solve this problem. Even though we cannot directly observe what's happening at the center of the cluster, estimating the distribution of the central mass in such clusters is possible by studying the motion of high-velocity stars. In simpler terms, if a high-velocity star is linked to a potential IMBH, its rapid speed can be attributed to a dynamic kick following a close encounter with the compact object. Moreover, certain models have indicated that if an IMBH exists at the heart of M4, there's a 33% probability of encountering a high-velocity star within the central region of the cluster. Remarkably, researchers managed to identify a high-velocity star in their observations of M4. In this figure from the research paper, the green star represents this high-velocity star. In the case of M4, mass is not spread across a large enough region of space to be a swarm of dense objects. This makes the newly detected black hole of M4 an intermediate mass black hole. Astronomers now aim to gather more data from the future observations of M4 by Hubble, Gaia, and the James Webb Space Telescope.